Okay, new kind of data structure. This is the most interesting one. So let's just quickly review what we have so far. Is that, well, we have list, and I'll have to quote it. So that's just a sequence of things. Well, it can be anything. It doesn't have to be just numbers. Okay, and in order to handle that, well, it is sort of awkward to access the elements because you can access the first one and we can access the rest one. And if you want to have the third one, then, well, you need to take the rest of the rest, then the first. So yeah, it is a bit awkward. But this is the most basic data type, and closure programs are represented in lists. And it's like, well, it makes sense because if it's a function call, you know that, well, you will need to go through all of them anyway. So to have better access to the elements, we have the vectors. Okay, and now what we have is that we can access the elements by indices. So it behaves as a function. And we can directly get to the element by giving the indices. Okay, so this is already sort of an associative data structure, because what we do, we associate numbers, integer numbers starting from 0 to the content. Okay, so it's the only thing is that this is very, very fixed. You only have you can only associate content with the numbers starting from 0, 1, 2, 3. And so maps, hash maps, they sort of abstract this away. Now it says that, well, yeah, sure, it's not just from numbers, but from anything to anything. You can have an association, and it's not called index anymore. It's called key value pair. So it's not index stored value. It's key value pairs. I copied over this. So this is an example of a hash map, and as you see, it is inside curly braces. So we have a new type of bracket. And if I evaluate it, well, this just says, so this is a data structure where the string answer is associated with number 42, and the string question with the question mark, number 2 with its its word representation, the word list, the string list with a particular list here, and you can even associate the empty list with the list containing 3. So it's like, well, yeah, these are just random association. It just says that, well, you can basically associate anything with anything else. Okay, so it's fairly abstract. One thing you can do is that if you want to help yourself, you might want to put comma there to emphasize that this is a key and value pair. Key value. Okay. So this is how you can imagine that sort of the storage here. It's so instead of 0, 1, 2, 3, 4, well, we have these keys. So actually the order doesn't really matter anymore because it's not numbered. The keys are not ordered. So it's like, well, this is a key value, okay, and they can be. Okay, how to use this? Let's just give it a name. Let's define as M, just as a map. Well, if you ask what is M, well, it evaluates to this hash map. But now you can ask, you can use it as a function. So what is associated with 2? Well, with number 2, well, that's the string representation, okay? And what is associated with the empty list? Well, the list containing 3, so it's a fairly random association. Okay, what happens if I ask something that is not in the hash map? Well, I get nothing, so I get nil. Okay, so if the key is not in the hash map, well, you just get nil. Okay, it's sort of important that it goes only one way. Okay, so it's 42 is stored as a value, but it's not stored as a key. So if I ask so what's the meaning of 42? Well, nothing. I don't know anything about it. So there are some handy tools here, and that you can ask for the keys. So this is the sequence of keys, and you can ask for the values. Okay, these are the values stored in the hash map. So, well, a hash map is quite a bad name. It's like, because we use map anyway, and the hash, well, that refers to the internal method, how the association is actually done, how it's implemented. What would be like a better name? Dictionary. Just like in the dictionary, you know, you have a string, well, it's the word, and you find the associated meaning with it. Or you might call it a lookup table. So it's a table where you can look up values. But it is fairly fundamental. As a special case, we can talk about the empty hash map. Okay, let's ask that. Well, what are the keys of that? Well, you get nil. It's nothing. It's not a collection of anything because it doesn't have keys. And if you ask for the values of the empty one, then you get nil as well. As I said, it's like, well, it's like you can use anything. You can be crazy and you can associate nothing, nil, well, with this. And now if you use it as a function, then you get nothing. So even this makes sense. So how to grow hash maps. So far I just put the I just use the literal for creating a hash map. Of course you can use conch. Let's say I have an empty hash map here, but the way I put the element. So it's like, how do I represent a key value pair while it's in a vector? Okay, so that's my key, and that's my value here. Okay, so this is how I can add a new element. So one element in the hash map is a key value pair. So, well, okay, that's another question here. If I look at my hash map M, and what's the number of elements here? Okay, well, it's like, you might have two answers. One is that, well, you count how many things are inside, and you will find, well, 10 things. But actually, a hash map contains key value pairs, and that's one thing. So therefore, this will tell us 5. Okay, and that makes sense because it's 5 key value pairs. You cannot store just a key in the hash map without a value. So therefore, it is counted like that. Okay, so to summarize, we introduced a new structure, data structure. List is the most fundamental, and that's just a sequence of things. With sequential access, we have to go through the elements to access them. Vectors, that's another sequence of elements where the order does matter, but we can access the elements by referring to their slot, their index. So that we can use numbers to access them. Hash maps, it's not exactly a sequence anymore because the order doesn't matter. It's just key value pairs. Okay, you can refer to the elements with the keys, and you can easily get the keys and the values, and you can associate anything with anything. So it's a very general dictionary. It's a lookup table.